Okay, the next thing that we're going to do is on each node we're going to install the clients. Now, we're going to just, for simplicity's sake, install them everywhere on the controller, network, and compute node. So the first thing we want to install is something called pip. And pip is great for installing packages with Python. So let's install pip this way. Yum install python pip. Actually, we put yum twice. We don't need to do that. This is going to go ahead and install pip. And there's actually, while we're doing this, there are 9 different components: ciliometer, cinder, glance, heat, keystone, neutron, nova, swift, and trove. Ciliometer is a telemetry API for billing and stuff. A cinder is for block storage, as in cinder block. Glance is for image storage, for instance, pre-installed OS image. Heat is the orchestration, where things are actually commanded. Keystone we installed previously. Now we're going to set up the clients. A neutron is the networking. And Nova is the actual compute API and the extensions with it. Swift is for storing objects, so it's kind of like S3 sort of, and Trove is for database services. So the first thing we're going to do is actually create a loop that does the following. For I in ciliometer, cinder, glance, heat, keystone, neutron, nova, swift, trove, do pip install python dash $i client. And what this is doing is actually installing them. It's just going through these one by one. Rather than having to type them one, we're actually running a tiny little script here. And we'll do this on each node accordingly. So let's go ahead and copy this, and it's actually going to error out because we spelled trove incorrectly. We put drove at the end, so that's going to error. You can see it's doing a whole bunch of stuff, running setup. If you've ever worked with Perl, this is very similar to CPAN. So it's installing the clients accordingly. So let's go to the next host and run it and type it correctly. So for I in cilium, sometimes typing slower is a little better. You can type 140 words a minute, but if half of them are incorrect, you're going to get an effective data rate that's much slower. So there's no point in winning the race and making a whole bunch of typos. There we go. For I, you can see, made a typo there. For I in do pip install python okay, let's do the same thing on the compute node. For I in one of the things that happens in the brain when you're typing is sometimes you type letters out of order because you're typing with 2 different hands, and different nerves can respond at different speeds. That's actually why people make typos, because the brain is not a synchronous computer. It's much more quantum in nature. Not that that matters for this. Okay, so we're going to have to go back, and it's the compute node. Okay, well that's working great. And you can see that it couldn't find the drove client because that doesn't exist. So we're going to install pip install python trove client. It's in treasure trove. Hopefully that will work. There we go. It's successful. So now we have to set environment variables. And let's see if we still have the, we do not have the password. We're kind of using this as our catch-all password. We might as well use change me. So, okay, we've installed everything except on the compute node, where it's installing Python. It looks like YAML, which is yet another markup language. So let's pause recording while that runs. So now that we've gone ahead and installed the OpenStack clients, the next thing we're going to do is set up a couple of RC files, and those are for setting account authentication information. I'm going to do these on the controller, and then I'm going to copy them into network and compute nodes. So the first thing is going to be admin-openrc.sh. And you can see we've already created this one previously. And so this should be present on, it's present on the controller. Let's check the network one. Okay, so it's not actually present on the network one. So let's go ahead and copy it from the network node and, I'm sorry, copy it from the controller node to the network node and the compute node. So we've copied it from controller. And let's go ahead and edit it. Now we're on the compute node. Same thing. See, it's called admin-openrc.sh. And we're pasting that in. Okay, so now we've created admin-openrc.sh. Now the next thing we're going to do is create a file called demo-openrc.sh, and that is essentially the same file, but instead of using the tenant name and username of admin, we're going to use the tenant name and username of demo. So let's go ahead and copy that to, I keep wanting to say open source instead of openrc.sh. And let's edit that file. And let's go ahead and copy that, the text from that, into our buffer. Go into the network node and do the same thing. Now, in truth, we probably don't need to do these on the controller and network nodes, just on the compute nodes. But for completeness in this, I'm doing it on all of them for uniformity. So it's called demo-openrc.sh. And lastly, on the compute node, rc.sh. And let's actually go ahead and connect using, we're going to source the admin openrc file on our compute node. So source admin openrc.sh. So now we're actually going to run an OpenStack command, and we've set the password. We can override it using the keystone command. But let's just go ahead and run the keystone command. Keystone service-list. Okay. And that's probably fine. That may have to do with the fact that the controller was actually rebooted. So let's take a look and let's run it directly from the controller. There's an os auth underscore URL which has, we haven't sourced it. We need to do that. We only sourced it on the compute node. So let's go ahead, and you can see that the controller node can now talk to itself. Let's go back to the compute node and see if that will work. Okay. It's possible that we don't have we don't have a firewall access to the controller node. So let's take a look and see if we can run netcat. Oh, we don't have netcat. Let's go ahead and install netcat. Maybe NC or netcat, I can't remember. And netcat is like a lightweight TCP connector client. And it's a great way to test if a remote host has a port open. If it's really not working, we'll just turn off IP tables just to verify. Because it's possible that we don't have. Okay. So now in the compute node, we've got netcat controller 5357, and it is not opening. Well, let's go over to the controller and just turn off IP tables. Let's go back to the compute. That's promising. So now let's go ahead and run that Keystone service list. So it looks like we have to do some modifications of our IP tables, which isn't a big deal. We can do that at some point. For security's sake, I'm going to turn this back on. Service IP tables start. Let's verify that that no longer works. Yeah, that's definitely an IP table, so that's fine. We'll open those up at some point and we'll document that. So we've demonstrated that we created the OpenRC.sh files that store the passwords that we created, and we've run Keystone, and you can see a service list. So at this point, the next thing we're going to do is configure the image service. And again, the image service controls actual images that will be used to spawn instances in our OpenStack cloud. We're going to go ahead and turn off the firewall to make things a little bit easier on this while we do the image service. So the image service is called Glance, and what that does is store images that can be used to stage instances in our OpenStack cloud. So the first thing is we're going to talk about the Glance API, and that's actually a web-based, actually not web-based, I'm sorry, RESTful API for image discovery, retrieval, and storage. And then there's the Glance registry, which actually stores and retrieves metadata about images. And things such as size, type, other things might be stored in their licensing. And the interesting thing about the registry is it's only for use by the image service. Users should not need to contact it. It's actually not secure in that fashion. So for this, we'll probably use MySQL to store this. So the first thing is we talk about the repository, the storage repository. And that's actually going to be just a directory. We're setting it up to use files. But ultimately, you'll probably want to use something like an NFS storage or an iSCSI SAN. So the first thing is we want to install the image service. So let's go ahead and, if you recall, let's store our password in the buffer. Okay, so m-y install. We're going to install OpenStack Glance and Python Glance client. Let's do the same thing on our network. Helps again if we spell things correctly. There are ways to have Linux do spell check on commands, but I find that to be a little bit scary sometimes. Okay, so it's installing on the controller, installing on the network, and let's install it on the compute node. Okay, so we're going to go ahead and pause this recording while these install. This could take a few minutes. It's about 46 packages. That's the controller, that's the network node, and that's our compute node. Okay, now we have installed the Glance client and OpenStack Glance. So let's go over to our compute node, and it looks like it's still installing over there. Our controller has it, our network node is installing. So let's take a look at our controller node. It seems to be significantly faster. I'm running within KVM. Oh, that's interesting. It's just one core. It might be on a different host node. So we're going to go ahead and pause this for now until this finishes installation. And then at that point, we're going to set up the configuration file. We're going to have it use the QPID message controller message broker for the image service. And then we're going to create a Glance database user. We're going to create a database, grant privileges to a role account called Glance. We're going to create the tables using a script called Glance manage db sync. And then we're going to create the account using Keystone. And then we need to run a bunch of commands that will actually set up the Glance user in the identity service. And then we're going to actually register an image and then we're going to verify it, and we're going to see what that image looks like in the database. So that should carry us through, and we'll have the image service set up. On the compute node, and let's just verify that we can talk to the controller. So we're going to run netcat controller 35357, and that's good. That's actually the address of the RESTful web interface that we use to talk to the controller. So we're going to run OpenStack config set etc glance-api.conf database, and then we'll break that onto the next line. Connection MySQL glance colon, and then we're pasting in that password at controller glance, and press enter, and then we're going to run OpenStack config set etc glance-registry.conf database connection MySQL and what we've done is we're telling the Glance registry and the Glance API to use the database we're running on the controller as the place for storing our tables. And so the next thing we want to do is set up using OpenStack config to use etc glance-api.conf default. That's the default stanza in the file, and we want to use RPC backend and QPID, and that's the message broker that we set up earlier. And then the next thing we want to do is set up the QPID hostname that the QPID message broker will use, and in this case it's controller. Helps if we spell things correctly. Okay, so now what we want to do is, and actually these steps that we took, we're going to have to run them on the controller as well. So let's go ahead and go back to the controller and run a step to create the database. So going back to the controller, MySQL -u root -p, and we're going to create the database glance, grant all privileges on glance.star to glance at localhost, identified by, oops, we're not going to do line breaks. Okay, grant all privileges on glance.star to glance at any host, identified by this. So essentially what this is saying is if a user logs in from either localhost or from any host to this database with this account, they have all privileges to this database and every table. And that's database.star. And so we need to do this. We actually have to go back and rerun the OpenStack config commands on the controller node. So let's go ahead and we're going to exit here. And the first thing we want to do is create the database schema. So it's su-s, that's to run this shell. This is actually a script that is designed to run in Bourne shell, so that's why we're explicitly telling it to use Bourne shell. And it's going to run a script called glance-manage with the option dbsync, and that's going to run as the user glance. Okay, so now we need to go back to, since we're on the controller node, let's go back and run the OpenStack config commands from the previous step. Okay, and then of course configuring the image service to use the message broker. Now one thing we can do is actually manually edit these config files. But the cool thing about this OpenStack config command is it handles all the formatting, and it will do some error checking, because it's very easy to make a typographical error and close up the command, the config file. So we're setting it up to use QPID. And this is, again, using the default stanza. And QPID hostname is controller. And we're going to go ahead and run these commands on the network node as well. So OpenStack config you can see we made a little bit of a typo there. The great thing is that we can change that, hopefully, CONNECTION. Okay, and so we've set the connection for Glance API. Now let's do the same thing for Glance Registry. It looks like we made a little bit of a typo here. So it's not fdatabase, it's connection. And this is glance to be passed at controller / glance. I actually made another typo in that we forgot to spell the file incorrectly. So that should read that. Okay, so now stack config -, set etc glance -API conf default PC backend QPID OpenStack config default. And we've already created, so we've run the OpenStack config, we've created the database table. Now what we need to do is create this keystone user called Glance. So let's try to do this from the compute node. We're going to do keystone user create. Name is Glance. Password equals pass equals, again, this is our magic pass that we're using everywhere. Email is glance@let's.net. That's good. We've gone ahead and create that. Now we need to create the role. Keystone role user role add user equals Glance tenant equals service, and it's an admin role. Okay, so now we've created the keystone. Okay, so we have a bunch of steps now that we need to do to configure the image service for authentication, image service to use the identity service. And we're going to go ahead and take a break now and resume this in a little bit. Okay, the next thing we need to do is set up the Glance API and the Glance registry config files. So let's run OpenStack config. Make sure that it's in the path. Okay. And there's going to be a lot of repetitive commands, so we're going to use the up arrow quite a bit. Set etc glance-api.conf keystone _ auth token auth URI, that's uniform resource identifier, to HTTP controller :5000. Now we have to have this password in the buffer so that we can paste it in there when we need it later on. Okay, so now we've set up the auth token, the auth URI. Now we're going to up arrow, and instead of this, we're going to change auth host to controller. Oops. Okay, and then we're going to set auth port to 35357. And then we're going to set auth protocol to HTTP. And then we're going to set admin tenant name to service. And we're going to change the admin user to glance. And then we're going to set the admin password. And then we're going to set something called paste deploy. Set the key flavor to Keystone. And so now we need to set up the glance registry file. So it's OpenStack config and we're going to change the Keystone auth token to auth URI controller 5000. And then we're going to set the auth host to controller. And these are analogous to the ones we set for the API.com. So we're doing the same thing for the glance registry. In theory, these can be different hosts, but this is a very simple model. So we set the auth host to controller. Now we're going to set the auth port to 35357. And next we're going to set the auth protocol to HTTP. And next we're going to set the admin tenant name to service. And next we're going to set the admin user to glance. And next we're going to set the admin password to this password that we've set before. And finally, we're going to change the paste underscore deploy flavor to Keystone. And so now we need to register the image service. We'll create the service. We'll register with Keystone. Name equals glance. Type equals image. And this is kind of a long command, so we're going to enter these on separate lines so that it's easy to read. Description is OpenStack image service. Ah, you know what? We rebooted this and we forgot to expecting either an auth URL via ether OS auth. Oh, yeah, it's interesting. Okay, so we need to source that file, not run it. There we go. We created the image service. We've enabled it. The name is glance, and it's the type of service is image. So the next thing we need to do is create the endpoint using Keystone. So Keystone. Okay, now what we're going to do is we're going to run this Keystone service list, and we're going to get an ID for that service. So Keystone and this is this one. We're going to copy that right there, using a slightly different copy so that we can paste using the keyboard instead of the screen buffer. There's two clipboards. This will just make it simpler. So Keystone endpoint create service -id equals that public URL HTTP controller 9292. Internal URL is the same thing. Admin URL equals the same thing. And go ahead and run that. And we've now created the endpoint. So now we need to start the Glance API and the registry. So service OpenStack Glance API start, and now we are going to do the same thing with registry, and this is a search and replace. That's just a shortcut that works great. And then now we need to turn the service on so that every reboot it runs. So OpenStack Glance API on, and then we want to do the same thing but with registry. Okay, so now we're actually going to verify the image service installation in the next section. And we're going to download a sample image and see if we are able to view it.